Hello and welcome to March 2021's Plumtree, and the topic is Great Observatories of the World. We've got a number of members who have prepared some short talks on an observatory that they visited or read about or done some research on, so they'll be coming up shortly. And then at the end of the talks, the speakers some of them will be available for answering questions that you may have, so you can pop those in the YouTube chat. Now, when we think of the term observatory, these days we think of a domed building with a telescope inside, but observatories have changed over time. The earliest probable astronomical observatories were about 7,000 years ago, stone circles. These were largely built for religious and spiritual reasons, and the alignments line up with celestial bodies such as the sun, the moon, and certain prominent stars. And people will have studied the motion of the night sky and the sky in the daytime, the sun too. And then over time, people have gone a step further. They've developed instruments to look at the sky, the astrolabe, and others. Tycho Brahe, before the invention of the telescope, had an observatory with instruments where he could accurately measure stellar positions to one another and study the motion of the planets. And then in 1609, the telescope came into being. Well, that's when we think it came into being, and that revolutionised our understanding of the night sky eventually. And that's probably when the conventional observatory came about, a building to house a permanently mounted telescope. Now, observatories today don't just house optical telescopes, they house telescopes which look at all different wavelengths of light, radio, and we even have telescopes that are not ground-based, so the Hubble Space Telescope and others. So, observatories are fascinating, and what we'll do is we'll have the talks and then we'll have some questions at the end. So I hope you enjoy the meeting. I'm grateful to all those who have contributed something. Here we go.
The King's Observatory is perhaps better known by its other name given to it during its lifetime, that of Kew Observatory. An observatory synonymous perhaps for meteorology rather than its original purpose as an astronomical observatory. The King's Observatory is actually situated in the borough of Richmond upon Thames and not in Kew, being located in the grounds of Richmond Park, which is just a short distance away from the Royal Botanical Gardens at Kew. The observatory that stands today is largely the same Georgian building that was built by King George III, and his portrait still hangs inside the observatory today. The building was designed by architect Sir William Chambers, who was also architect of Somerset House. It was originally built as an observatory specifically for the King to review the transit of Venus on the 3rd of June 1769, which was successfully observed by the King at the observatory. The present-day building is largely the same as that built in 1769, but for the addition of 2 rooms on the upper floor shown here, which were added sometime in the following decade, and this sketch of the observatory shows how it would originally have looked. This is a view taken from the roof of the observatory from one of the first ever public tours of the observatory that I went on in 2019 of what is now a private house. And you can see the view outside looking over the old Deer Park, which is now surrounded by the Royal Mid-Surrey Golf Club, which makes for a very interesting arrival to the observatory as you drive down the road towards the observatory, having to dodge flying golf balls. And you can see in the distance here the Royal Botanical Gardens at Kew, so it's not located that far away from Kew Gardens. Situated behind me is the original observatory dome, and it's the oldest example of this type of cupola observatory in the world. Let's look inside. You can see the original wooden dome structure still there to this day. The actual telescope that was used to observe the transit isn't this one that's actually inside it now. After a bit of research, I did manage to track down that the telescope looks very similar to this one here. It's a 4.5-inch reflecting telescope manufactured by Thomas and James Short of Edinburgh, and the exact telescope is that was used now actually on display inside the Amar Observatory. And I couldn't find a copyright-free image of that, but if you go to the Amar Observatory website, you go on their virtual tour. If you look in the boardroom, you can see the original telescope used by the King to observe the transit on display on top of the piano. This diagram from papers on display inside the observatory of what they actually saw during the transit. They saw the start of the transit as the disk of the planet entered onto the sun's disk quite late in the evening, just after 7 o'clock in the evening. So they didn't see the full event as Venus set, as the sun set above the horizon, but they did manage to observe the transit, and it was only an hour, so they did really well to see that, and the observatory saw the event that it was actually constructed to observe by the King. After King George's death in 1820, successive monarchs had little interest in the observatory, with it becoming run down and largely disused. The collection of fine scientific and mathematical instruments, and also clocks which were displayed inside these original Georgian display cabinets, were broken up and sent to museums and observatories around the country. But instruments was to form an important part of the observatory's later history. And ownership passed from royal hands in 1814 to the British Association for the Advancement of Science, which we now know as the British Science Association. Under the BA, it became Kew Observatory after losing its royal connection, with the site still concentrating on solar astronomy, and it was also to become the birthplace of modern solar terrestrial physics, and probably what Kew will remain in the history books as being most well known for. It started with the discovery then by Henrik Schwaber that sunspot frequency went up and down in a 10 or 11 year cycle, with the then chairman of the newly formed Kew Committee, Edwin Sabin, making the connection between this sunspot cycle being in tandem with fluctuations in the terrestrial magnetic field. Edwin Sabin provided the instruments to make these observations of terrestrial magnetism at Kew, and decided to follow up his discovery by using the site to take records of sunspot activity using the new Kew photoheliograph, which was designed by Warren de la Rue. It wasn't actually used inside the main observatory building, but in huts built in the grounds of the observatory, and it was the first systematic observations of sunspot ever taken. The development basically used new techniques, photographic techniques, allowing them to take very short exposures of the sun, which were required to make plates of the sun with exposures down to a hundredth of a second. The instruments were in place in time to see the Carrington white light flare of the 1st of September 1859, which was well documented by observations at Kew, and saw huge jumps on the magnetometers, and the photoheliograph captured the very famous Carrington event, and it was some of the very earliest photographs of sunspots that were ever taken. And this image just shows the photoheliograph on the left hand side with an example of 2 images taken by it. By 1871, the heavy burden on the BA finances of Kew led to it being acquired by the Royal Society, following a trust fund of £10,000 gifted to the Royal Society by John Gassiot for the purpose of continuing the magnetic and meteorological observations with self-recording instruments. At this time, the solar photographing programme was abandoned, and the Kew photoheliograph was actually lent to the Astronomer Royal at Greenwich Observatory. But Kew saw the commercial opportunities, the Royal Society saw the commercial opportunities for Kew to self-fund itself through the standardisation and testing of instrumentation, which was originally started by the BA. And Kew became the new National Physical Laboratory for testing and standardisation of instruments. And the very much sought after Kew mark, which is shown here on the left-hand side, on the right-hand side, was put on instruments that had received calibration at Kew. By the early 1900s, the spread of the electric tramcars in London had led to excessive electromagnetic interference at the magnetometers at Kew, So they were relocated to the Eskdale Observatory in Scotland in 1908, and they continued there to this day as the UK National Environmental Observatory, which is managed by the British Geological Survey, whose headquarters are just down the road at Keyworth. On the 21st of February 1910, Kew Observatory became solely occupied by the Meteorological Office, and Kew remained the central observatory that all Meteorological Office instruments were verified against. At this time, the National Physical Laboratory activities were transferred to new offices in Teddington. During the next half-century, the Met Office used the site to calibrate radio sondes and did a lot of pioneering work in the design and calibration of the automatic sensors that were to be used in some of the Met Office automatic weather stations. The photo barograph was also developed at Kew, and the Kew pattern became recognised as a specification for barometers and thermometers worldwide. So the weather observations had been made at Kew ever since the observatory was established in the 1700s, and you can see this image of the thermometer screen that was on the northern wall of the observatory. But the Met Office decided to close the observatory due to the costs of maintaining the building, and these measurements were eventually ceased following the sale of the building in 1980 into private ownership. And the last observation was taken at Kew on the 31st of December 1980 at 9 o'clock GMT by Tin O'Donovan. But observations for the Kew record do continue just down the road in this observatory. There's an automatic observatory at Kew Gardens. Today, the leaseholding of the King's Observatory is in private ownership by Robbie Brothers, who's a Hong Kong businessman. He's taken some really extensive renovations of the house to turn it into a domestic use, and he's also returned the ground largely back to the surroundings, more akin to the time of the original building. And this image was taken during the demolition of many of the outbuildings that were built subsequently for a lot of the meteorological and the magnetometers to be housed in. They were demolished and a new lake built. Over the years, in private ownership, the building has been leased as offices for companies such as Autoglass, but it does remain part of the Crown estate, and the leasehold will transfer back to the Crown in 2117. But at the moment, the owner is leasing the building out as a residential property for just £37,000 a month. So I'd like to end by looking at an interesting association between astronomical observatories at many observing locations around the UK and also in Europe. A lot of the astronomical observatories are co-located with very long meteorological observations, and I guess weather conditions not only affect whether you can make observations, but also have a key role in the quality that the observation can be made. And it's quite interesting to look at many of these observatories that have very long meteorological records. So Radcliffe Observatory having one of the longest running records in the world, and Amar Observatory, all co-located alongside astronomical observatories. And if we look wider in Europe, that situation is also true with the astronomical observatory at Stockholm in Sweden, having the longest continuous record of weather observations in the world. I've slightly run over time, apologies about that. If you do want to look at more details, there's some great books on the King's Observatory. Lee McDonald's got one that I'd particularly recommend. So thank you very much for listening.
Hi, good evening, everyone. I'd like to talk about the Greenwich Observatory. This is one of the ones I have visited, although I didn't get a chance to actually observe the telescope there. Because of the increasing trade with other countries, there's a need to have a more reliable navigation and timekeeping. And this was the basis of actually having the observatory on the site where the Greenwich Castle was initially built, high up on a hill in London, and this seemed a suitable site. So it's a requisition by King James II, The first astronomer royal was John Flamsteed, who put the foundation stone there back in 1675. He was actually there for about 40 years and made about 50,000 observations of the sky. With the help of Edmund Halley, who is also a well-known astronomer, they managed to plot all the stars in the northern and southern hemispheres. Just to give you some details about the telescope, it was a 28-inch refractor. It weighed 200 pounds and was 25 feet long, and it was used for about 70 years to measure the double stars, which are actually about 50% of all stars. This will actually help in measuring the size and mass of these stars, which will be very useful in the future. The telescope had to be moved during the First and Second World Wars to keep it safe. Also, because of increasing pollution in London, it was moved in 1957 to Hirschmonceau Castle, where it's kept for a number of years until 1975, when it's brought back because of celebrating the 300th anniversary of the observatory. It was actually mounted on a English equatorial mount, which was actually constructed 30 years previously, and had to be the telescope had to be narrowed in the centre to get it fitting correctly. The Greenwich Observatory was also well recognised for timekeeping, which was very important for seafarers. And in 1833, time ball was set up on the roof of the Flamsteed House, and this was dropped at 1 p.m. exactly every day, so that seafarers could see exactly what the time is before they set sail. The Queen at the time, Queen Anne, gave royal assent to a prize for finding the longitude at sea, which was really important for seafarers, so they could get to their destination with more accuracy. This was accomplished by a person called John Harrison, who was a carpenter but had a special interest in clockmaking, and he made 4 variations of the clock, which gave more and more accuracy over time, and he won this prize of £10,000, which is equivalent to £1.5 million in the present day. I hope this talk would make you want to visit Greenwich Observatory more so, if you haven't already done so. Thank you for listening.
Good evening, everybody. I'm Mike Provo, and tonight I'm going to talk about a telescope known as the Leviathan of Parsonstown, which I came across quite by accident on a business trip to Ireland in November 2015. So, why is this a great observatory? Because our understanding of the deep sky started right here 176 years ago. Next. The Leviathan of Parsonstown, or Ross 6-foot telescope, is a 72-inch aperture f8.7 Newtonian reflecting telescope of great historical importance, because it started the work that led to the proper understanding of nebulae, galaxies, and other deep sky objects. William Parsons, the 3rd Earl of Ross, built it on his estate at Burr, County Offaly in Ireland, in about 1845, and it was the biggest telescope in the world until the Hooker telescope came along in 1917. From 1874 to 1878, Dreyer used the telescope to begin the compilation of his famous NGC catalogue, which we all use. William Parsons' son, the 4th Earl, and his associates continued to operate the telescope until about 1890. And after his death, the telescope was partially dismantled. But following renewed interest shown by Patrick Moore in the 1970s, the telescope became a visitor attraction, and it was rebuilt in 1996 and 97 based on research done by an Irish engineer called Michael Tubridy. A new aluminium mirror was installed in 1999. Next. The main components are shown on this slide. There are two supporting walls arranged north-south, 40 feet high and 71 feet long, placed 23 feet apart. Between them, there's an optical tube, 6 feet diameter, 72 inches, 52 feet 6 inches long, weighing 12 tons, including either a 3 or 4 ton mirror at the other end from the one you can see. This moves in altitude from pointing towards or nearly towards Polaris to pointing almost to the southern horizon. Movement in azimuth is restricted to about 15 degrees, allowing about an hour's viewing on any object within reach at any given point. A system of winches, chains, and counterweights moves the optical tube. To look through it, there are two viewing positions. The viewing platform at the top for higher altitudes is placed on the top of the west wall and moves in and out to get the observer's eye near the eyepiece. At lower elevations, there's a viewing gallery which moves east-west along a support frame with rails that can position the observer near the eyepiece. That support frame, which you can see at the bottom, moves up and down some sloping supports so it can follow the altitude of the optical tube. Next. This is showing just a few of the details at the south end. The eyepiece is shown at the top left in the black oval. The red oval shows the mechanism used to alter the azimuth of the telescope. The observer is expected to turn a handle to move the telescope in azimuth as it moves across the sky. The viewing gallery is shown in the orange oval, moving on its support frame in the purple oval. There are some other bits and pieces that I don't know about, though I suspect they're to do with choosing different eyepieces throughout the night. There is no finder scope. You have to put on bigger eyepieces in order to find your target. The upper viewing platform is shown here. The access steps are tucked in between some buttresses on the west wall. The viewing platform, as I said earlier, moves in and out to follow the telescope as it swings through its azimuth. At the north end, at the bottom, there's a cover covering the mirror and the universal pivot joint, which allows the telescope to move. There are several winches, a big set of frames carrying support chains that allow the telescope to be lifted up and down in altitude. And interestingly, in the bottom right, there's a little railway, which was needed for swapping the mirrors around between observations. Next. A drawing of the M51 Whirlpool galaxy is shown in the top left, based on observations made using the Leviathan. There are his notebooks in a museum nearby, one of which is shown in the bottom left. The box for one of the two mirrors, one weighed 3 tons and one weighs 4 tons, is shown in the top right. That's sitting on a trolley that's used to move them between the telescope and the workshops. The mirrors were swapped around after each observing session and polished using steam-driven machinery before each use. Technology, as always, moves on, and the Leviathan fell into disuse as smaller and more manoeuvrable telescopes became available, and it was realized that photography was a better way to study the heavens. So over 176 years, we've moved from a device 6 feet diameter, 53 feet long, 12 tons, weight to something that sits in a backpack, very small, and takes some absolutely brilliant photographs. Thank you very much.
Hello, I'm going to tell you about the GTC, the Grand Telescopio Canarias, which is situated on the island of La Palma in the Canaries. It's the largest single aperture telescope in the world, with an aperture of 10.4 meters. So it's slightly larger than the two Keck telescopes in Hawaii. I was able to visit the GTC in 2015 when I was staying at a resort near the capital, Santa Cruz. On the top of the island, there are many observatories because it's said to be one of the best observing locations in the whole of the Northern Hemisphere. The GTC has 36 hexagonal mirror sections with spare ones that can be replaced and re-illuminized in a facility in the basement of the observatory. The telescope became fully operational in 2009. Here are some photos that I took on my visit. The first one is looking down on the observatory. The second picture is a view of the dome at ground level. The third picture is a shot of the telescope pointing vertically with the massive dome and slit overhead. The fourth picture is a photo of the visiting party looking towards the main mirror. And the fifth picture is a closer view of the main mirror. Finally, some video clips from my visit, approaching the main telescope site by coach. A general view inside the observatory.
So now we're going to go through the mirrors. Another thing I want to say, by the way, just in case anyone is thinking, there are no lenses, okay? Forget about lenses. Everyone is familiar with your old spyglass type telescope or refractor.
And two clips of the telescope and dome slewing.
Well, most people found the primary mirror and hope. The dome is also moving at the moment. The dome is turning. And the telescope's going up in elevation. But the telescope is not turning. No, that's when the telescope is on
Hello, my name is Sam, and I've got this short talk about the Palomar Observatory in California. This observatory has been close to my attention for quite a long time because during my formative years in the 1950s and when I first got hooked on astronomy, the large telescope at Palomar was the largest optical telescope in the world. It was fairly new on the scene, and it was a big step up from the previous largest telescope at Mount Wilson. Palomar is in Southern California. It's about 2 hours drive from San Diego. It's 1,700 meters up in the hills. It's got quite a number of telescopes, but the biggest and the best known is the 200-inch Hale telescope, just over 5 meters aperture. I got a chance to visit this in 1993 when I was on a business trip to San Diego, and I used my free weekend to go and visit Palomar and tick something off my bucket list. I'm obliged to inform you that all the images in this talk are taken from Palomar Observatory and California Institute of Technology. So here we have an aerial view of the site showing the dome of the large telescope in the middle there. Quite a pleasant sight. It's got good seeing, good clear skies generally. And here is the large Hale telescope viewed end on. This is the 60-inch telescope on the same site. And here we have a 48-inch Schmidt camera. Back to the Hale telescope, which is the main attraction, and this is the dome. Okay, a brief summary of its history. Actual work started in 1935, although this telescope had been a gleam in someone's eye for a long time before that. In fact, soon after the Mount Wilson 100-inch had been opened in 1917. The Hale telescope saw its first light in 1949, and it remained the largest optical telescope in the world until 1976, when the Russians came up with something slightly bigger. The main mirror is a parabolic mirror, and it's equipped with both Cassegrain and Coude focusers to suit different modes of operation. The main mirror, which was cast from a single piece of glass, it now weighs 13 tons, but 5 tons were taken off during the process of grinding and polishing. It took 13 years to make, thanks partly to delays due to the war. And the whole telescope is 481 tons. Here we have a shot of the dome under construction in the 1940s. And here is a drawing, a very detailed technical drawing of how the telescope was planned to look. There was a whole series of these detailed technical drawings prepared by the principal designer before a single piece of the telescope was put together. And this shows the main mirror straight after being cast. It's got all these sort of holes on the underside to save weight. The mirror was cast at a glass factory in New York and then transported overland to Pasadena in California, ready for grinding and polishing. So this is part of the transportation process. And here we have the mirror on the grinding and polishing machine at Caltech in Pasadena. And here we have the before and after pictures. Before at the top is the mirror before being polished, and after below is after the polishing process. And this shows the mirror being got ready for being lifted into position in the telescope. This is what typically happens during maintenance, which has to happen whenever the mirror needs re-illuminizing, which is about every 18 months. Okay, and this is a general view of the scope. You can see the yoke mount, which is a modified version of an equatorial fork mount. Remember, the aperture is just over 5 meters high, wide, 5 meters wide. So this is a seriously big beast that we're looking here. A close-up of the telescope within its mount, pointing straight up at the night sky. And here we can see the observer's cage down at the bottom with someone standing in it. Another view of the scope looking up at the night sky. At the top, there's another observer's cage where the observer can be close to the prime focus if necessary. That would be useful for loading films in. And this is the scope pointing almost to the North Pole. On the right of this picture, you can see the maintenance cart. When the mirror is being got ready for maintenance, it will be lowered down onto this cart and then placed in the vacuum chamber, which you can see to your left, which is where the vacuum aluminizing takes place. And here we see a guided tour taking place with the visitors' observation gallery just behind. Okay. Since 1949, of course, there have been modern improvements. The scope is now under computer control. It's fully equipped for digital imaging, so no one looks through eyepieces anymore. And it's now equipped with adaptive optics to enable it to deal with atmospheric disturbances. It's used for the whole gamut of astronomical observation, deep sky imaging, measuring the evolution of stars and the expansion of the cosmos. It's equipped for spectrography. It has been used for detailed imaging of planetary surfaces, and it's currently carrying out some research into exoplanets. So there we are, the 200-inch telescope still going, still on top of its game after 72 years. And I hope you've enjoyed this short talk.
Good evening. It's Bas Traxfield here from the NAS giving a talk on the Paris Observatory. I'll start by moving on to the next slide and asking the question, where is it? It's in Paris, obviously, but it's easy for me to look at a very old map of Paris from about the 1870s and 1880s when there were less buildings around and the place looks a little more legible. The map is actually on its side, so north is where the Seine is, south is the other side. Where my cursor is there is the actual observatory on the Rue de l'Observatoire, which makes sense. Right, this is very much how it looked when it was first built. I'll just give you a little bit of history behind it. It certainly doesn't look like that now. This is taken from a print which I managed to find in an auction somewhere some time ago. Well, the Paris Observatory is the oldest of the great Western observatories still in use. The observatory became famous through its research and discoveries from many, many scientists in the going back to the 1700s. They played an important part in the development of several things: the celestial mechanics and astrophysics. It helped give birth to the new science of geodesy, cartography, and modern meteorology. It was also intimately associated with the origin of the metric system. And as you can see here, from when it was first built, it was built in 1667 and finished in 1672. And it was under the order of Louis XIV, the Sun King. He employed various architects to produce it, and you can see there it's a rather grand building, but certainly not as it appears today. It was a couple of stories shorter than it is now. Right, this was literally almost after it was built, and obviously very popular. In the background there's all sorts of various types of astronomical instruments, a quadrant over there. Notice that in those times, very, very long focal length telescopes. And the main thing about the orientation of it is actually built along the line of the Paris Meridian, which it was designed that way so that the meridian itself actually bisects the building. And this is taken from the front, and this is how it is today. Very much the rather ornate scroll work there was as in the last picture. The most modern addition to it being this dome, which houses a large telescope. Facing south, that's the north face of it. Again, I'll explain about that a bit later on, but you can see the dome, which is actually on the south side. I've been many years wanting to go to the Paris Observatory, and it's always been closed. I've always looked at the website, and it's in French and very unhelpful to people like myself. So I thought, am I ever going to see it? And then there's a chance meeting at the FAS in Birmingham, meeting where Valles Gabode gave a talk on gravitational waves, and it turns out he was from the Paris Observatory. So I just casually asked, any chance of a visit round? And he said, well, we're not open to the public. So it looked a bit dire. Then I suddenly thought, well, if I asked some members of the Society for the History of Astronomy and we could ask for a guided tour, then something might happen. And it's exactly what happened in the end. In May of 2017, a whole series of History of Astronomy people went to the Paris Observatory and had a day out looking around the observatory, and then all sorts of other wonderful places in Paris afterwards. It was a joint meeting with the Society for the History of Astronomy, the Société Astronomique de France, and the Observatory de Paris. This is basically just before we actually went into the building officially. And again, I'm just pointing out this nice scroll work, which is on the original etchings. So this is actually inside the observatory, and this is where a meeting was held. We had a whole load of papers exchanged between the History of Astronomy group, the French side and the English side. So we had a really good day out, and I kept sneaking out to take pictures. I think that's the, I can't remember, that's Louis XIV or not, and Cassini's there as well. The inside the observatory is actually a museum, and the museum itself has just got fantastic things in there, all relating to all the studies over the many years. The museum actually housed the Academy of Sciences in France, where they established something called the Paris School, and that had all sorts of famous people besides Cassini himself. I call him Cassini one because there were several over the centuries. Jean Picard, Adrien Alzou, I'm not sure what he's done, Christian Huygens, and various other French astronomers. I'm afraid I'm going to have to leave that to others to look up and research who they all are. But some very historically important features are in here. Cassini himself, Cassini number one, observed from the second floor of the observatory, and he studied the moon. And we can see an example here of his lunar map, and there's also accompanying that a rather grand map of the heavens. That's another map of the moon. I think it's Cassini, but it's remarkably clear given the instrumentation at the time. This, again, is part of the museum, and you can probably see various telescopes and quadrants, too many to actually pick out any in particular. This is Cassini's very first map of the moon, which is very famous indeed, incredibly detailed. There's a log of some of his original observations, and in this particular case, he's seen from the observatory a comet. I'm not sure which one it is. And this telescope was used by Napoleon to peer across the channel to see what we were up to. This is one of the typical quadrants that were used by the various French cartographers to map their detailed map of France based on the French meridian. I won't go into details about how that differs from the English one, but it is different. And I think the French wanted to dominate the world by having one central world meridian. And in the end, they chose Greenwich, but it doesn't really matter. You've got to draw the line somewhere. This is a rather fantastic ornate globe. It's all gold leaf and a very detailed globe. I can't remember who made it or when, but it is old. From the museum, you could go up the steps into the fantastic, makes you feel ill looking at that, the meridian room. And you can see on the left is the meridian line carved into the floor. It's all polished marble with a brass strip. And in the window at the end, you can see just at the top a little pinhole, which is where the light is let in, which at midday illuminates the meridian strip below. And here's an example where at midday or something thereabouts, astronomically equivalent, you can see a rather nicely focused spot of light gradually crossing the meridian line. And so exciting was the event that was a sort of impromptu conga along the meridian line. Right, onto the roof. And this is a fine view looking north along the Paris meridian as it is today. And the next one is how it was about 200 years ago. I can't remember the names of all the churches and domes because there's so many of them, but if you just cast your eye on that particular one where the cursor is, the following picture shows that as it is in modern times with the sun out. It's a fine view. It's not Capitol Hill, but some other dome of which there are so many in Paris. And talking of domes, this is the main dome with the big telescope in it from the Paris Observatory. It's not that old. I think it's 19th century. And inside of that is the main refractor, which is a 15-inch refractor. I think it's Brunner made it. I'm not familiar with that person. Yeah, so it's a 15-inch refractor, but it's been used for all sorts of things. It's in a very smart dome indeed, and that's it from another angle. If only we had a dome that size, it would be quite useful, actually. Not too many holes in. The ones that are there are to let the light in. The wonderful steps as well. These are perfectly safe to stand on, and I don't know how many famous astronomers have sat there observing. It's quite incredible I managed to, even though people, when they weren't looking, I did sit down for a bit of a rest on the steps. And this is just from beneath the telescope, just the gear mechanism. And that's some wonderful Heath Robinson type. I should be careful what I say here. Timing mechanisms for the motor drive, and almost there now. On the ground floor of the observatory, which is now actually the basement, there are several telescopes there as well. Again, I won't dwell on them, but there was a big exhibition in Paris at 1900 for some enormous telescope that was on display. I'm not sure if it's still in existence, but on the right-hand side is the mirror that went into that scope. I shall finish there, but it's important to realize that Messier, Charles Messier, lived in Paris, and he had his own observatory, and it's in the Hotel Cluny, which is just south of the Seine. And I think he observed somewhere up in this tower. Yes, I think it's there. It's changed a little bit, but it's at the time when the skies are all dark. You could have meaningful observations.
Good evening, everyone. Given tonight's topic, I wanted to pay a brief tribute to the recently demised Arecibo radio telescope. For over 50 years, Arecibo was the largest single aperture telescope in the world, and combined this with being the world's most powerful radar. Probably best known to the general public as the villain's lair in the James Bond film GoldenEye, it was the go-to image for film and TV when talk of contact with alien civilizations was on the menu. The dish had its origins in the work of this man, Bill Gordon, a professor at Cornell University who studied the ionosphere during the 1950s. His work led to the idea of determining its properties by analysing backscatter from a radar beam. He determined that he would require a very large dish and a very powerful transmitter. The initial proposal in 1958 envisioned a 300-metre parabolic reflector with a fixed tower at the centre supporting the receiver. This was the height of the Cold War, and with Russia ahead in the space race, the US military quickly took an interest and directed Cornell to other research groups. The idea developed into a spherical dish with a steerable cable-mounted aerial allowing the telescope to scan up to 20 degrees from the azimuth. During 1959, funding was obtained from the Advanced Research Projects Agency, and the search was on for a suitable site. It was evident that the dish could not be self-supporting, so a suitably shaped and sized natural depression was required, and this was discovered in a sinkhole in the limestone landscape of Puerto Rico. Construction by the US Air Force began in June 1960, and the telescope was operational by late summer 1963. The 600-ton receiver platform was put into place first, suspended 140 metres above the dish, using 18 main cables running from 3 reinforced concrete towers back anchored to the ground. Each corner of the platform was further connected to the ground beneath the reflector by 3 pairs of cables mounted on jacks, allowing positioning of the platform to millimetre precision. Below the triangular frame of the upper platform is a circular track on which the azimuth arm turns. The azimuth arm is a bow-shaped structure 100 metres long, and hanging below the carriage house are various linear antennae, each tuned to a narrow band of frequencies. The dish was constructed from a network of steel cables anchored to the rock and could be manually adjusted. The original reflector had a wire mesh surface focused on the 430 MHz line feed. In the early 1970s, the surface was replaced by nearly 40,000 1 metre by 2 metre precisely formed aluminium panels, allowing the telescope to operate up to 3 GHz. A second upgrade, completed in 1997, replaced the original line feeds with a Gregorian reflector system housed in a 6-storey dome. As we can see in this diagram, the 22-metre secondary reflector feeds an 8-metre tertiary reflector, which in turn feed the array of instruments mounted on a rotating floor within the dome, and this permitted operation up to 10 GHz. Also included in the upgrade was a mesh ground screen around the perimeter of the dish, seen here, and a new 1 megawatt transmitter for planetary imaging. This permitted imaging down to 1 kilometre on the surface of Venus and 15 metres for near-Earth objects. The typical field of view is about 3 arc minutes, with a pointing accuracy of 5 arc seconds. After many years of underfunding and damage from both earthquakes and tropical storms, the structure suffered a number of cable failures, culminated in the 900-ton receiver structure crashing to the ground on the 1st of December 2020, bringing to an end 57 years of work across a range of scientific fields. The final catastrophic events are shown here. Whilst the video plays out, here are some examples of the research carried out at Arecibo. In 1965, studies established that the Mercurian day was 59 Earth days, overturning the belief that it was locked to the 88-day Mercurian year. In 1967, Arecibo saw the pulsar at the centre of the Cloud Nebula flashing over 33 milliseconds, cementing the idea that they are rapidly spinning neutron stars and not pulsating white dwarfs. The 1970s saw the imaging of the surface of Venus below its thick blanket of clouds, showing past tectonic and volcanic activity. In the 1970s, researchers using the Arecibo facility were able to observe pulsars orbiting companion stars and deduce energy loss consistent with the production of gravitational waves as predicted by general relativity. Arecibo has a long association with the SETI project, and in 1974 the most powerful broadcast ever deliberately beamed into space was made using the 1 megawatt transmitter. Aimed at the M31 globular cluster, 31,000 light-years away, this was largely an exercise to promote ideas rather than a genuine attempt to communicate with aliens. In the 1980s, it saw the discovery of fast pulsars siphoning mass from companion stars. The planetary radar identified potential ice on the surface of Mercury, and the dish has also been used to establish the size and trajectory of near-Earth asteroids. The dish will now be dismantled and contamination removed. The future for this type of instrument is left to the Chinese 500-metre Aperture Spherical Telescope, or FAST, which became fully operational in 2020. Thank you.
Right, thank you all. That was superb. I really enjoyed watching all of those, and I'm glad that I'm not the only one who goes on a holiday and does lots of astronomy viewing and taking lots of snaps. But yeah, it's superb, everyone. So thanks all for your contributions this evening and preparing all those talks. Right, we've got I think most of our speakers poised on Zoom to answer any questions that anyone wants to throw at them. So please do put your questions into live chat. So I'll display that on the screen there. There's about a 30-second delay on this, but we'll work around that. Right, so all the speakers should be able to unmute yourselves, and if you want to share your video, please feel free. So I'll probably kick off a first round of questions then whilst we wait for those to come in on YouTube. So I'll go in order then. So start one quick one with Herbal first. So does the ball that rises at noon, does that still operate today? Do we know if that still functions? Oh, I think you're on mute, Herbal. I'll just see if I can unmute you. No, can't get Herbal, so we'll perhaps come back to that one in a bit. I can see Mike's on. So, Mike, did Williams Parsons use or make telescopes prior to making the Leviathan?
Yes, I believe he did. The pictures in the, let me just put my video on. I don't know if you can see the cover of the book that I bought, but next to the picture of the 72-inch is a picture, a drawing of the, he had a 36-inch telescope, very much like the one William Herschel used to use near it. And also, I think it's an 18-inch telescope, which he had built in an observatory between the two large telescopes. And it was when he sort of worked with photography on the 36-inch and also the 18-inch and spectroscopy as well. He was one of the first people to measure the temperature of the moon, apparently, that the big 72-inch fell into disuse. So yes, he had a number of telescopes. The 72-inch was there to try and resolve the question of, were these fuzzies, you know, collections of stars or collections of gas that were, you know, condensing into stars, and it never really answered the question. And many observers looking through it, you know, saw both effects from the same object. It was a source of some controversy, but it was certainly an interesting telescope to build.
Do you think it was more a publicity stunt to make it the largest telescope in the world at the time?
The view was that the bigger the aperture, the more ability you'd have to resolve whether these fuzzy objects were nebulae or collections of stars. And William Parsons was an engineer by trade. In fact, his son, Charles, was the inventor of the steam turbine. Mm-hmm. And it was said that it was as much an engineering project as an astronomical project. He built it as an engineering challenge as much as anything. What really let it down was the speculum mirrors. They had very poor reflectivity, to the extent that his big 72-inch telescope was probably equivalent to a 25-inch telescope today.
Mm-hmm. It's certainly impressive. I'm amazed that, yeah, it's interesting to build an instrument that had such small movement in its azimuth. You'd have thought that would have put them off building something like that, but there we go. Patience and hope for clear nights at the exact time you need.
Apparently, it was a very poor place to build a telescope because there was a bog nearby which let off plenty of fog, and of course it rains a lot in Ireland, so they didn't actually get a huge amount of observing it from it as much as they would have liked.
Yeah, stressful when you're trying to observe a particular thing. You've got a short window to get it.
Yes.
Yeah. Has anyone ever been killed up there? It looks a bit dangerous.
It was said that the upper galleries were very scary until you'd been on it a few times. There's no record of anybody being seriously hurt. The only complaints were from the various workers who were winding the winches during the night. You know, they were fed up of being kept up all night.
Yeah, Bet health and safety is a bit different then as well.
Absolutely.
Cool. Okay. I just had a message from Herbal. He's got a noisy granddaughter, so he can't be on Zoom, but he's not aware of the time ball is still working on that. I don't know if anyone else is. They can put that on the chat. Follow
James,
up.
James has got a question.
Do you want to take that?
Book? The book that James recommended to me, which is very interesting, is called William Parsons, 3rd Earl of Ross, Astronomy and the Castle in 19th Century Ireland. I got it from Amazon, about £18. Not only does it discuss the history of the telescope, but it also discusses what William Parsons did in Irish politics, because he was a well-heeled landowner. Have I frozen?
No, I can still. Well, I can still hear you fine.
Yeah, and his wife Mary was a very early photographer. There's a big chapter devoted to what she did, so it's quite a fascinating book.
Yeah, great stuff. Anyone else on the call want to ask Mike a question? Feel free. Otherwise, I'll go down the list and we'll get some more questions to the other speakers. So, Roy, let's come to you now. Lots of telescopes down in the Canary Islands. What factors make the GTC such an excellent site for astronomy then?
So have you, I can't make myself visible. When I try to put the video on, it says you've stopped it. Is there any way you can put it on?
Alt V.
Let's have a look. See if we can get you asked to start video. There we go. If not, we can hear you fine, but yeah, I can see you now.
Yeah. Oh, gracious me. There are plenty of big telescopes up there, some famous ones. I can't remember them all now, including, I think, gamma ray telescopes, massive mirrors, huge things, just out in the open. I just can't remember all of the others actually that they're arrayed around the top of the crater, because of course it's a volcanic top to the island.
Yeah. A massive mirror like that. What is it? Did they get issued with mirror flop? Was that discussed at all?
Well, it's what the adaptive optics is all about, right, isn't it?
And that compensates for it to some extent.
Yeah. The system, as with lots of those big telescopes, is a Ritchie-Chrétien system. So the primary mirror is hyperbolic, and so is the secondary as well.
Yeah.
And it gives an effective focal length of something like 170 meters, which is about, what, 100 times the focal length of typical amateur telescopes that you and I might have. Yeah.
Cool. And is there any, have you got a list of any major discoveries made by that telescope?
Of course, I look for images, and they're all sort of copyright. It would have been nice to have shown some of the prettier images. They've got a lovely image of Stephan's quintet and various gaseous nebulae. If you just go to the website, you can see what particular research programs are involved in, and I can't actually quote any specific discovery. That's the way science is these days.
If anyone can pop a link to their website, then perhaps put that in the live chat if anyone's got a computer and can do that. Question from James: does the sea salt cause trouble there, or is it too high up?
It's a long way up. I mean, it's nearly 8,000 feet. Somebody said, can I explain why it's such a good observing site? I'm not sure. It's the most westerly of the Canary Islands, way out in the Atlantic Ocean. Instinctively, you think that air over an ocean might be rather unstable, but technically, I don't know why, but obviously they spent a lot of research trying to find a good site. And the neighbouring island of Tenerife has quite a lot of decent observatories there, but nothing as big as the ones on La Palma.
James also asked, can you hire time on any of the scopes in the Canaries?
Yeah, I think so. I think it's the remote kind where it's the one something to do with Liverpool University up there, where you can obviously by a remote link actually make use of that telescope.
Yeah, be interesting to know the ratio of clear nights there, wouldn't it? Imagine it's very, very high.
On top of the Canary Islands, they talk about there being over 300 clear nights a year. I think that applies to the top of Tenerife and the top of La Palma.
Yeah, pretty impressive. Brilliant. Okay, let's go down to Sam. Hopefully Sam's with us. I can see his mic's okay. Your camera on. Good. I think actually a question that came in during your talk just dropped off the list. So let me just pull it back up. There we go. From Fred. So is California subject to big earthquakes? Was anything done to harden the scope against these when it was being built?
Well, I couldn't find any reference to earthquake protection on the Palomar website or in this guidebook that I brought back from Palomar. But I would say that the site was chosen for its stability, its geological stability, amongst other things. It's quite some distance inland, so it's not near the San Andreas Fault. I've just done a quick Google to find if there have been any earthquakes there. And indeed, there was a small one, magnitude 3.5, not long ago. And the small earthquakes are fairly frequent, but there have not been any big ones recorded. So to the best of my knowledge, there isn't any specific earthquake hardening. But the dome is very solidly built. And as you've seen from the pictures, the telescope is quite a massive beast. There have not been any reports of earthquake damage or earthquake disturbance.
No, quite lucky. It'd be interesting when they get the next big one there to see what happens.
Yeah, I suspect the next big one, if and when it happens, might be some distance to the west where the San Andreas Fault is located.
Yeah. I think you said in your talk, it took, was it about 13, 14 years to build it?
Yeah, the mirror itself, it was 13 years from the first casting to the final polishing. Wow. That included some delay because of the war. But it actually took a very long time for the molten glass to cool down and to stabilize. And of course, there was a very long process of repeated grinding and more grinding, and then polishing and aluminizing.
So was the production of the mirror the limitation in time, more so than the superstructure of the site?
Well, I mean, if there'd not been the war, maybe 5 or 6 years might have been saved.
Yeah. Impressive achievement at that time, particularly with, I guess, the lack of sort of resources, money at the time to build it. And I'm surprised that didn't hold it up even more, let alone labour shortage.
Well, I suspect the Americans threw whatever money it needed at it.
Yeah. And so the actual site that they chose, it looked quite sort of picturesque, I suppose. There's not a lot around it. When they established that scope, was there anything there before it, or was the establishment of the site for the Hale scope the start of the observatory there?
To the best of my knowledge, it was an empty site. It was just a good site high up in the hills at a good altitude. They did some research into the weather patterns and the geological stability and concluded that Palomar was as good as any. One factor, of course, was the relative lack of light pollution. Because Mount Wilson, where the 100-inch Hooker telescope is located, was beginning to suffer from light pollution from Los Angeles as the city expanded. So it was decided to have the new observatory even further from Los Angeles. And now, of course, it's beginning to suffer from pollution from that direction. You can't win, really. I suppose the only answer is to put observatories in the middle of deserts.
Yeah. Right. Let's move on to the next one. Thanks, Sam, for that. Barry, we don't have Barry on the call, unfortunately, to answer any questions. So if anyone's got any for Baz, pop those on the live chat, and you may pick them up. I was just interested to know. One question was whether the Carte du Ciel project, whether that was that site was used as one of the telescopes for that project. So I don't know if anyone knows the answer to that one and wants to pop that in the live chat. Something from David Anderson there. So yeah, according to the website, the time ball at Greenwich is still operational. So hopefully that answers that question that we had earlier. I was going to ask Barry as well, that map that Cassini produced of the moon, how was that actually made? We're quite interested to know that one. Sam, one for you, I think, if you're still there. Does the 200-inch have an eyepiece, or is it just for photographic?
Well, nowadays, no one looks through eyepieces. I mean, we're all aware of the much greater advantages of digital imaging, and it will be a waste of valuable telescope time to have someone squinting through a bit of glass. So there is no eyepiece observation going on these days.
It'd be quite a thrill, though, wouldn't it, to go and have a look?
Yes.
I often think it would be just amazing to look at some of these big scopes through an eyepiece if you ever got the chance to do it. Right.
Can I make a comment?
Yeah, no problem.
I was just about to say, regarding light pollution and eyepieces and all of that, one of the problems with the Leviathan was that the only way of recording things was sketching. And so they had to have a lamp above the sketch pad. Yeah. And every time the guy looked to make the sketch, he lost his night vision. So it was a terribly painful process to record anything through the eyepiece that had any true scientific meaning.
Yeah, quite a challenge. Last but not least, Tony. I can see Tony's on the line. Thanks for your talk. I guess you had to do the one that was a bit of a sad news story, unfortunately, but there we go. I guess what my question is there any future for that site now, or is that it, I presume?
No, I think they're very much hoping that the site can use its other instruments and have a future. It's one of those things where it's an important tourist site as far as Puerto Rico is concerned. They get a lot of visitors, and they certainly want to keep that scientific sort of centre there, using the other instruments. Once again, funding is the major issue. They've struggled to have sufficient funding there for a long period of time. Cornell gave up on it, and the operation moved to the University of Central Florida. But with NASA reducing their funding and other funding streams reducing, they simply couldn't maintain the main dish. But they do have about 5 or 6 other instruments there. There's still quite a lot of skills there with regard to the studying of the ionosphere. They've got a separate site that has exciters that are sent up into the ionosphere to be studied, and the actual studying of the ionosphere doesn't anything like the size of dish that was built. And in fact, they did do a miscalculation in the first place, and they didn't really need that a dish as big as it was anyway.
Any thoughts on why the Americans chose Puerto Rico? Was there anything suitable on US mainland, or was there just after that sort of latitude?
There was 2 things really. They knew originally they were going to build it in New York State, but they realized that they needed to go south. So the first thought was Hawaii, but because Cornell University, they were quite keen on the idea of having something on the East Coast rather than on the West Coast, for the traveling of the actual observers. And then they realized that what they needed, natural depression. And there's very little in terms of anything on US mainland with a suitable landscape for that to happen. And it was almost by chance that they hit upon Puerto Rico. And in fact, Bill Gordon spent a whole summer around the hills of Puerto Rico looking for the site, which was essentially at the time tobacco fields.
Mm-hmm.
But they realized that if they could find a hole the right shape and size, then the construction cost would be massively reduced because they would have so little earth to actually move.
Yeah.
But the site had no add to the biggest issue of the construction was actually getting the material to the site. But the one thing they did have was the logistics and equipment of the US Air Force.
Mm-hmm. Yeah. Was it part of the square kilometre array project? And if it was, is it not leaving a big hole in it? No, it wasn't. Okay. Yeah.
No, it's never part of it. No.
Right. Yeah.
No. And as I say, the radar side of it was as much a part of its operation as the actual dish.
Mm-hmm. Yeah. Okay. So what's the immediate sort of loss that we've sort of had as a scientific community from the result of its destruction?
Well, I guess it is the radar side probably that's the biggest single loss, because things like planetary imaging and the near Earth objects, whilst it's not much good at actually detecting near Earth objects, what it's very good at is, once they've been optically identified, actually working out their physical size, shape and trajectory very quickly. Yeah. So that will be a hole in the NASA's ability to actually determine the risk from any near Earth objects.
Yeah. Hopefully a good factor in getting some sort of replacement up of similar stature.
Yeah, well, I think in essence it's really moved on, I think, from an investment point of view to arrays, because the great thing that arrays do over a single dish is you get much better resolution.
Yeah.
And obviously with Meerkat coming on stream and then the square kilometre array, that effectively fills in that radio telescope aspect. Obviously the Chinese FAST telescope went operational last year as well, fully operational last year. And in fact, with that one, because they don't have such a big platform, they actually only, even though I think it's big again, they only actually use the meters of the dish at any point in time, because they've got a bigger, they can move further away from the azimuth. But obviously, as you move away from the center of the dish, you're effectively losing aperture.
Yeah. Brilliant. Thank you, Tony, for that. Oh, another one from James just nipped in the bottom there. Was ASIBO used to communicate with spacecraft at all?
Yes, it was. It was used a number of times to communicate and wake up deep space probes. And there's of people, it's not within its standard operation, so that actually had to be done by people plugging in up in the dome, in the Gregorian dome itself. So they would literally have to swap the plug over to send the signal, and then swap the plug back at the appropriate point when it was going to be coming back to actually receive the signal back. But when we've got the cable car up to the receiver platform or the skywalk to get there, and then you've got to walk up and down about 8 or 9 stories of steps suspended 140 meters above the center of the dome.
Impressive stuff.
Yeah.
It's amazing what goes into all this that people probably just not aware of.
Yeah.
Cool. Well, thanks, Tony. Just a quick opportunity. If there's anyone, any of the speakers want to ask any of the other speakers a quick question, please do so now. No. Okay. So I'm going to finish with a quick one. I was quite interested as I was sitting here thinking, which of our speakers has been the furthest away in the globe to see an observatory or telescope, perhaps either? So, any advances on the Hale telescope?
I did see the Christchurch telescope. I didn't go into it, but I did make a point of going to see it when I was down in Christchurch in New Zealand.
Cool. That's probably the winner then, I think. Cool. Well, thanks very much all for all your hard work and efforts putting in to prepare those talks. I know it takes quite a long while, and also thanks very much to Lee for putting all those videos together, because that was quite a big job in itself. So
yes, thanks, Lee.
Yeah, thanks very much all, and also to James for arranging it all and getting our speakers tonight. Super stuff. Right. To finish up quickly, what's going off in our meetings program? Where are we? So next meeting, April, 1st of April. Yeah, so it's our year anniversary of being online, unfortunately. That is one of the, not far away from Roy's talk. So Astronomical Adventures in Tenerife by Dave Eagle. So it'd be a good talk. So that will be on Zoom, usual time, 8 o'clock. I'm not sure what the next Plumtree meeting is going to be, so I'll wait and send you some emails when we know exactly what that's going to be on. But next one is on Thursday, the 15th of April, 8 p.m. So we'll send details in due course of what we plan to do for the next Plumtree meeting. Finally, sorry, I don't like putting this up, but it's membership renewal time. I think many people have joined again. So thanks so much for supporting the society. Whilst we've had to do this all online, it's really good to see so many people have rejoined. If you haven't, or if you're new to the society and have enjoyed watching some of our free meetings on YouTube, we'd love you to join us. So our membership runs on a yearly basis, so those are the different rates. If you want to see more details or join, just go to the NAS website and click on the membership and you can get a form. But yeah, we'd love you to join us in the society. So I think that's about all we've got time for this evening. Again, a huge thanks for everyone for putting the effort to prepare tonight's talks on the observatories. I really enjoyed that evening. It's good. We'll have to do something similar again soon. So we'll see you on the 1st of April for our next meeting. Until then, from all of us, a very good evening.